Hi, welcome back to DATQVAULT video lectures. In this lecture, we're going to go over the Aldol condensation. Aldol condensation is a very popular reaction in organic chemistry, and you're probably likely to see a question about the Aldol condensation on the DAT. So, the Aldol condensation is a reaction between two different carbonyl compounds with either an acid or a base catalyst to get this type of aldol product over here on the right. When the aldol condensation is done under heat or is let go long enough, then this aldol product will eliminate or dehydrate to form this alpha beta unsaturated carbonyl product. This carbon being the alpha carbon and the carbon over here being the beta carbon. So the aldol condensation can be done either under acidic or basic conditions. So we'll go over the mechanism first of the aldol condensation under basic conditions. So the first thing that happens in an aldol condensation is the base will deprotonate one of the carbonyl compounds. You'll know which carbonyl will be deprotonated because it'll be the one with the most acidic proton. The aldehyde over here, benzaldehyde, this hydrogen right here is not very acidic because once it's deprotonated, it does not have a very good resonance structure. But acetone right here, if you deprotonate this hydrogen, it does have a resonance structure, so this will be the carbonyl that the base will actually react with. The reaction of the carbonyl with the base looks like this. The base will deprotonate this hydrogen, and then the electrons will go onto this carbon, forming this carb anion. But a more stable resonance form of this carb anion is, of course, the enolate form of the carb anion, where the electrons get pushed up onto the oxygen, which better stabilizes the negative charge. So these two are, of course, in resonance with each other, but the enolate form is what's formed most, and it'll be the reactant for the aldehyde up here, which will form our aldol product. So the reaction of the enolate with the aldehyde looks like this. The negative charge will come down off of the oxygen to reform our carbonyl, and then the double bond will form the very electrophilic carbon of the aldehyde. So once this reaction goes, we get a negative charge on the oxygen of the aldehyde. We get our negatively charged aldol product, which then goes to deprotonate the methanol that is formed from the deprotonation of the original carbonyl, and then we form our aldol condensation product. So like I said earlier, we can actually do this product with acid as well, but the reaction looks a little bit different when we draw the mechanism out. The mechanism for the reaction of the carbonyl with acid first starts again with our product that can form the enolate, but instead of forming an enolate, we'll actually form an enol through a tautomerization reaction. So first, an electron pair from the carbonyl will deprotonate our acid, and through tautomerization, we'll get this enol. So what we're doing is transferring the proton down here from this carbon up onto the oxygen, and that happens under acidic conditions. Once the carbonyl becomes protonated, the conjugate base of this acid will then deprotonate this hydrogen here to form our enol. It's the enol that acts as the reactant that will condense onto benzaldehyde in this reaction. The condensation of the enol with benzaldehyde looks like this. Lone pair of electrons come down from the enol, then the double bond will attack the electrophilic carbon of the aldehyde, pushing the electrons from the double bond up onto oxygen. Once this reaction happens, we get this product over here. Some base, such as water, will deprotonate this hydrogen, and the electrons will go back onto the carbonyl, giving us our aldol condensation product and water as a byproduct. All right, so let's do a sample DAT question. In this question, we're asked what molecule is needed to obtain the aldol product here shown on the right hand side of the equation. So why don't you take a second, try to solve this problem, pause the video, and then we'll go over it together. Alright, so in this question we're asked for a reactant which forms this aldol product here on the right hand side. So actually the easiest way to do this problem is to draw out the product, and then we're going to figure out which carbons and oxygens come from formaldehyde over here, and then which carbons are going to come from the other reactant. So formaldehyde has no acidic protons on it, so it is not going to form the enolate, and it's actually going to form the alcohol portion of the product. Formaldehyde has one carbon right here, and this oxygen is going to go to form the alcohol. So this portion of the molecule right here is going to be from formaldehyde, and this bond right here is the bond that's formed from the enolate. We can easily identify the other portion of the molecule, which is right here. If we draw this molecule out, this is the molecule that forms the enolate and ends up reacting with formaldehyde to give us our product. Substrate B over here is going to be the only answer that matches this product. Alright, so like I said, once we form our aldol condensation product, we can actually heat the reaction up to do an elimination or a dehydration reaction. This can be done with either acid or base. This is what the mechanism looks like when the dehydration happens with base. The base will come around and it'll deprotonate the most acidic proton on the substrate, which is this proton right here between the carbonyl and the alcohol. Once the base deprotonates that, the electrons first will get pushed up onto the carbonyl. These two things are in resonance with each other. The electrons, lone pair of electrons from this negatively charged oxygen will then come down to reform the carbonyl. This double bond will hop over to this bond, and then the OH will be lost. So we get hydroxide as a byproduct of this reaction, and here we get our alpha-beta unsaturated carbonyl. This reaction can also be done under acidic conditions. The mechanism for the acidic conditions look like this. The OH of the alcohol will first be protonated by the acid. Once that happens, we get some kind of a base, probably water or the conjugate acid of the conjugate base of this acid will deprotonate this proton. We'll form our double bond, and then we'll lose water as a byproduct in this reaction, forming again our alpha-beta unsaturated carbonyl. Alright, so for the examples I showed you guys before, we used acetone, and we also used benzaldehyde as our other aldol reactant. Benzaldehyde does not have an acidic proton, so it can actually not form either an enolate or an enol under the aldol conditions. But what if we have two different substrates that can both form enols or enolates? We're going to get a wide array or a wide mixture of different products in that case. So here I have an example where we have benzophenone and we also have acetone, which can both possibly form enolates under basic conditions and condense on each other. So why don't you take a second, pause the video, and try to draw all the different products that can come from this reaction with benzophenone and acetone under basic conditions, and then we'll go over all the products together. Alright, so there's actually quite a plethora of different products that can come from this reaction. The first product is where benzophenone here on the left hand side will get deprotonated by the base and act as the enolate, and if it condenses with acetone, it'll form this product down here, benzophenone being our enolate. so if acetone over here becomes our enolate, it'll condense with benzophenone to make this product over here on the right. Not only can these two reactants react with each other, but they can also react with themselves in a dimerization reaction. So an example of this would be acetone being the enolate and also being the aldol acceptor. If this happens, then we form this dimerization product down here. Also, if benzophenone is the enolate and also the enolate acceptor, then we get this large product down here. So from this aldol condensation with these two substrates, we actually have 4 possible products. So usually to control an aldol condensation, you'll only have one substrate that can actually form either an enolate or an enol. And then you'll only have one substrate being the enolate acceptor, which you will usually use a large excess of so that the enolate will not react with itself in an aldol condensation. Alright, so this sums up aldol condensations. Very important reaction to know for the DAT. So if you want to practice your aldol condensation knowledge that you've learned from this lecture, go ahead and take a quiz or try to answer a few practice problems on aldol condensations.